Hello, people. What is going on? What's going on for me is I am out of snacks. This is a really bad situation. I am snackless. Seriously, I got nothing here, snack-wise. Hey, if you don't want to stay up, it'll be on YouTube. Thanks for streaming all this. As someone who's not a programmer, it's awesome to get some in-depth knowledge applied to an actual thing. Why would you watch this if you're not a programmer? I don't understand that, but okay. I'm glad you're getting something out of the stream. You could feel free to go to bed. This will be on YouTube. It'll be viewable. Yeah, if I had realized that I don't have any snacks, I might have gone to the store. It's going to be hard to go without snacks. Go now. No, we're committed. We started the stream. We're going to do the stream. Are there any questions? Can't I get chocolate delivery? Probably. Do I think learning OpenGL and C++ is worth it in 2019? I would not. Especially not OpenGL, but probably not C++ either. I would start with, like, what do you want to do? Right? What kind of work do you want to do? And then pick languages appropriate to that. Which might be, if it's video games, it might be C++, but I would take a very compartmentalized approach to how much C++ I was willing to learn. Just go next door and ask for candy. That's a good idea. That's a good idea. Do we have 1 or 2-bit bools? No. No, we haven't done that. I thought about adding that early in the language, and the reason I haven't is that you can sort of get bitten by those. The memory model for parallel programming on machines like this has at best a byte granularity, right? So you could write a byte and that can have predictable results, right? But if you write a thing that looks like an independent value and say that's from some other thread, right? If it's a sub-byte size, this can result in confusing things happening, right? Maybe that's not a very good reason not to do it. I don't know. But it's just a feature of C that I never used. Like I might have used bit fields once like 25 years ago just to do it. It's just not that useful of a thing, I don't think. That said, I use, explicit bit flags all the time, and we might come up with some more ways of just making those more convenient, which might effectively end up being a similar thing, just done differently. Are bit fields a worthwhile concept? Well, I mean, I've never used them. And I don't even remember why. Like, it might just be that support in C is not very good for bit fields. Do compile time types mess up any IntelliSense autocomplete if you use it? I assume you mean types generated at compile time. So what we do, let me see if I can find this. Let me see. So we actually, when we generate code like that, normally it goes to, it goes into a file that can be used by the debugger, right? So, however, this time we didn't save that out. I'm not sure if that's because we're not doing that with body text right now, or if it's because we don't do it unless you set something anymore. I'm not sure. But anyway, in principle, you set it up so that stuff goes to these files, right? And then your debugger can step through those files, right? If there's code or whatever. If you look up a symbol declaration, it has a file to refer it to. The compiler doesn't actually use these files during compilation because that would be slower. The compiler just feeds itself the data, but we save it out to a backing file just in case. You program, but it's not your job. Okay, that makes more sense, honestly. You're implementing a dynamic scripting language for educational purposes. What you say is a good language feature to group data in a dynamic language. I don't like dynamic languages, so I can't really answer the question. I don't think they're a good idea at all. Despite having made several of them back in my younger days, I do not have opinions about them. I don't think you should do one. Can you override functions at runtime? You mean by declaring new things at runtime that replace the old ones or are overloaded with them? No. I mean, of course you can do that if you make a function pointer, so make a function pointer. Like, this is not the kind of language where you do goofy stuff like that, though, if I understand the question correctly. You're only familiar with Go generate where you run it before and generated types simply exist as source code lines. Yeah, I don't know much about that. I haven't followed it. How's it going? How's it going? What are my thoughts about Java SE? I don't know anything about Java anything. I've never programmed in Java. Although, I will show you this wonderful link that Casey sent me today. This seems pretty good. If you want to learn Java, you could go to this page, I think. Because you can't just make a request. Never mind that making so this is so amazing because there is literally nothing about doing any actual work anywhere on this page, right? What is like making a request? That's just like a communication that you would like to somehow set up or perform some work. No actual work occurs anywhere on this page. And yet you have requests, you have request processors, request processor factories, and request processor factory factories. You have 4 levels of indirection away from actually doing any actual work. So that is not how we do things downtown. This is all the Java I know, is what's on this page right here. Factories are the heart of any good economy. Yeah. Will there be any features to help multi-threaded programming? Yes. Do we have any yet? Not really. Factory should be a video game, right? I'm going to play Infinifactory Factory. However, the question arises when and how the request processor is created and whether it needs to request specific initialization. That is not the question that arises for me. Many more basic questions arise for me. Okay, I'm going to get this off my screen. It's gross. That. Oh, what happened to my buffer where I said I need to get my buffer back up? Which one of these is it? Not that one. There we go. Pre-stream Q&A, man. When you have a macro expanded loop that has a custom break implementation and you exit outside the loop to an outer loop or returning from a function, the break implementation doesn't get run, right? Okay, so that, you know, this is referring to the demo that I showed maybe a month ago or something, and we might have seen a little bit of it in the past couple streams. The break implementation only gets run when you break from the specific loop that macro is replacing, right? If you break from a more outer loop or you break from a more inner loop, it doesn't apply, right? It's very specifically only for that one loop. Any other questions? Programming questions. We're going to start in a few more minutes. 3 more minutes, 4 more minutes. I'm going to heat up some tea water for Winnie the Pooh. And then we'll start. But questions? So if you want something to reliably happen when you break from a loop, you have to use defer anyway. Well, I don't understand the question then. Give me an example of what you're talking about. Like, you shouldn't be replacing break to make something happen when you break from a loop. That is not the intention. The intention of that piece of functionality is just to make break do the right thing. You have to break from the right place. Otherwise, loop substitution doesn't work, right? So if you have a different goal, like you want something to happen at the end or something, then yeah, you should do that a different way. How SVN friendly is our game engine? Every time you pull in Unity, it takes 20 minutes re-importing everything. No, we don't take that long. The biggest thing that happens is if somebody updates a lot of textures, we recompress them, but that's something that I'm going to fix because it annoys me, and it is fixable. But even then, it's only like 30 seconds. It's not a long time. That's one thing that all the major game engines do a very bad job about, is being efficient with people's time when it comes to batch processing. Is there a way to label loops? You could break out of an outer loop from a nested loop. Yes, we demoed that. It's on YouTube. I don't remember which video, but you can find it. Is it possible to write an entire program in reverse using the defer command for every line? I'm sure it is. Except the problem is that things in the body of the defer are there, like, don't go into the outer scope. So you wouldn't be able to declare a variable later and use it earlier, which you wouldn't be able to do anyway. So that would be hard. But hey, if it's functional programming, then you don't need to do that anyway. So you said in the past was that break can always do the right thing by being effectively a go-to to the point right after the loop. You said break might want to do some other thing like setting a sentinel, but that doesn't make sense. Look, all I mean is break might want to do whatever it needs to do in order to correctly end iteration. You don't know what that is because the data structure might need any particular thing, or just the way that it's running might need any particular thing. It might not just be a go-to, is all I'm saying. How do you handle turnaround? Does each compile reload resources from scratch? What do you mean what resources? And what do you mean by turnaround? Do you mean the compile, edit, debug cycle? I'm not sure. So you have a loop where it creates a vector to iterate over during the loop. I would expect the break to free the memory allocated for that, but that wouldn't happen when breaking to an outer loop, would it? Where it creates a vector to iterate over during the loop. At the place where you create the vector, put a defer that frees it. I don't think you should create a vector. I think you should create an array, because a vector is a point in a space that is closed under addition and scalar multiplication. It is not, as Bjarne Strostrup thinks, an array of elements. All right. right, we have some tea. We'll be starting imminently. Question about defer. What happens if you go to over the defer? We don't have go to right now, so it's not a problem. If you were to go to over the defer, we would have to decide. But I think the defer would probably still happen, and we'd give you a warning or something. I don't know. You don't think there are actually any cases where you want break to be something other than a go-to outside the loop scope? I don't know. It's not really the topic that I'm thinking about tonight. So, yeah, I mean, it's possible that that might be true. But I mean, remember, there's multiple loop control variables as well. So there's break, there's continue. You definitely want continue to be something besides a go-to, right? For break, you might need to know, for example, whether somebody broke or whether they continued to the end, you know, and exited normally. I don't know. It just doesn't seem. Doesn't seem like something I'm going to worry about, but it's possible. Like, you know, all the things. Whenever we show an implementation of something, it's always the current implementation, right? It's never written in stone. Tried out delaying, just importing their standard regex adds like 4 seconds of compile time, apparently due to all the CTFE and template craziness. Have we seen any problems there with too much metaprogramming? No, not yet, but that's why I want to do a little more metaprogramming to put it through its paces and make sure that everything is good. I always do, though, say, like I compare a lot about compile time, right? So like say that you wanted to encrypt some data and put the encrypted string in your program, and the data doesn't usually change. It is less error prone to just encrypt it every time. But then you're spending that time, and that time costs you something. So I would just say encrypt it once and put the result string in your program, and don't be running compile time execution all the time, right? So like, programming, the history of programming is full of people getting really excited about ideas and using them too much. You don't want to use anything too much, and that especially includes compile time execution, although it is very useful in cases where it's useful, right? But we'll see. You know, the way this compiler works, it runs your stuff in parallel with its own compilation process, trying to keep the bottlenecking minimal. So you won't slow down until you're doing enough compile time execution that it extends the amount of compile time, right? But that might not be that hard. Who knows? Well, that feels like enough pre-stream chat. Continue is also a go-to? No, that is not true. Sorry. Anyway. I don't think it's true. We'll see. That'll be a discussion to get into some other time. And then remove is definitely not a go-to, so yeah. Okay, so let's make a new file. Just going to import some stuff. empty file. Look, it doesn't do anything. Ta-da. Okay, thank you everybody for coming by. Today, we're going to do some more metaprogramming. For the past couple days, we had some fun using metaprogramming to do a command line argument parser. That module probably isn't complete. It will get expanded in the future, but it's pretty nice. It's pretty fun for what it is. And so I want to do some more metaprogramming to do SOA, structive arrays kinds of things. In the early demos of this programming language, I demoed an SOA feature that was a built-in to the language, but I deprecated it a while ago because I didn't like how much complexity that it was adding to the core semantics, and I felt like it was a little too specific. It didn't cover every use case that you would want SOA for, and by the time we did cover every use case, it would have more of a performance impact, and I wasn't happy with that. So I've had a general plan for about a year of what's the better way to do SOA plus some other things. But of course, because we're all very busy, I've been doing other things than that. But we're finally at the point where I'm thinking, maybe we can take some steps there. So in the roadmap that I have in my mind for how to do SOA, there's a user level component and a compiler feature component, right? And the user level component is, hey, let's use the features we already have to get as much SOA functionality as possible, right? And then we should get to a point where, we can make data structures that have nice memory properties and stuff, but there's still a little bit of an interoperability problem because functions that don't expect to take those structures won't be able to. This will still be much better than something like C++ gives us, but once we get there, there will be some compiler features that we can add to get us even much further. But I figured that today would be a nice day to actually do some of the user level portion of that, right? Now, a lot of people, some people who frequently attend this channel and channels like this probably know what SOA is, but a lot of people may not. So we'll talk about that for a second. Probably more than a second, probably many minutes, right? Okay. So one thing that programs want to do a lot is math. They want to do a lot of math on things. For example, 3D games want to do a lot of transforming points in space, whatever. Lots of different kinds of math. What does math look like? Well, I'm not going to be specifically writing code here. I'm just kind of doodling in this buffer that's the same. Let's make a new buffer. Let's make a new buffer. Okay. So let's say you want to do some operation like x plus a, where x is like some coordinate and a is like a constant, right? Well, you don't usually want to do that just for one thing. Say I've got a bunch of points, like all the points in an object, and I want to do this operation for all of them, right? Then the C style thing would be like, for I equals 0, I is less than 67,432, I plus plus, x of I plus equals a, right? So you're doing the same operation on a bunch of things. And that's fine, but there are ways that you could start to do this faster, right? So starting a while back, CPUs recognized that it's a common thing that you might want to do to perform an operation like this on a number of pieces of data at once, right? And so this paradigm was concocted called SIMD, right? There are a bunch of things. There's also like a MIMD and there's sort of a MISD, although not really. Like nobody ever does that. But for acronym closure, MISD is a thing. Anyway, so what this stands for is single instruction, multiple data, right? And the observation is like, well, if we know that we want to have programs that do a bunch of additions, for example, then instead of just having one little thing on the chip that adds, and in reality, there's actually more than one, but just talking hypothetically, instead of just having one little thing on the chip that adds, let's pack some number of them together really close. So we could have like 4 of them, right? And then on your chip, you might be able to do like x1 plus a, x2 plus a, x3 plus a, and x4 plus a, all at the same time, right? And so instructions are added to let you do this. So this would all happen, for example, if you're lucky, if you're on a good chip, then you can do these 4 additions in maybe one cycle. Who knows about latency versus throughput, whatever. But in theory, you could probably do this in the same time as it used to take you to do that. And you could imagine that that makes your program a lot faster. Like, wow, I could do things 4 times faster, maybe. I could do things 8 times faster. If it's like 8 wide, you'd say this is 4 wide, right? And so forth. However, there is always a but, right? And here's the but. It's a big but in this case, so Sir Mix-a-Lot should be happy. The way that this sort of thing works is that the SIMD registers typically for these instruction sets are much bigger than the usual registers, right? So a typical register might have been 32 bits or 64 bits. Let's just say 32 bits. This is back in the days before we went 64-bit maybe, right? And so these X's are just single precision floats, so they're all 32 bits, right? So this is one 32-bit operation, floating point. This is a 4-wide 32-bit operation, floating point, right? Okay. Well, how do these X1, X2, X3, X4 get into these adders so that the CPU can do them all at the same time? Well, you got to put them there. How do you put them there? Well, if you had to just go do 4 separate loads, right, and then do the add, right? If your scalar, whoops, if your scalar add looks like load and then add, right, and your vector add looks like load, 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 add, well, you might say it's still faster, right? Because 4 of these would have been this, right? And now we do this, so it's 5 instructions instead of 8. So that's not that much faster, right? We wanted 4 times faster, and it's not. But also, CPUs doing things out of order. These loads are things that could typically be slow. They overlap with each other anyway, right? And so, I don't know. I mean, the performance of this, I guess, is unpredictable. But if it's slow, it's going to be dominated by load. It's not going to be dominated by add, right? So saving a few adds is not necessarily that great, right? You would like to not have to do all this work, right? Instead of saying load, 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 add, you want to just be like load, add. You know what I mean? And you want to be sure that this load goes as fast as possible, okay? That I don't feel like that was the greatest explanation, but it'll have to do for now. So what does that mean? What does it mean to load these things in, right? Well, okay. This is where Intel used to fight with game developers all the time, and still does probably, right? So say my points in my game are vector 3s, right? So I'm going to go C style again here for a second. I've got a struct vector 3, right? It's x, y, z. Oops, I'm float x, y, z, right? No surprise there. Okay, if I have a bunch of these in memory, if I've got my 60,000 of these in memory that we were talking about, how are they laid out? Well, if we assume that the alignment of this is 4 so that we can pack these tightly together, then we go like x, y, z, 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 right? Okay. Now we're talking about 3D points all of a sudden, so we don't just want to do x plus a. Or let's keep it to that. Like you might want to do things to y and z also, right? But let's just say for now, we still just want to add a to all the x coordinates and not do anything else, right? In order to load the x coordinates out of here, you have to read things that are like, let's just say buff is the pointer to the base of this array. We're gonna cast our array of vectors 3s to like an array of floats or something, and it's called buff, right? You want buff sub 0, right? Buff sub 3, buff sub 6, buff sub 9. Those are your first 4 loads, right? And if we turn that into bytes, it's like buff plus 0, buff plus 12, buff plus 24, buff plus 36. And so how do you get these memory locations into a SIMD vector without issuing a bunch of loads that may also have math? Because like you're adding to the buff here, right? And depending on how much the instruction lets you calculate, I mean, maybe you have to like load integer constants. Like it could turn into a mess really fast, right? Well, that's what SOA is for. Right? So people like Intel were like, you know, this is way back in the days of SSE1 or whatever. People like Intel were like, hey, you dumb game developers, right? How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 10. So hey, you dumb game developers, instead of storing stuff like this, why don't you just store all your data in your entire program in the following way? Just put all the x's together, and then all the y's together, and then all the z's together. And you could even imagine that they're not quite contiguous. So maybe they're even in different places in memory, but they're like this, right? And then the benefit of this is if you want to load the 4 x's and do something with them, you just say load 128 bytes starting at this address. And it's very simple. Bam! You go from memory into the register, and then the register goes to the math unit and does the thing, right? Okay. First of all, as someone said in chat, but my object orientations, right? And that's true. But, you know, I'm not a big fan of object-oriented either, but it's true that like programmers want to think about the vector, right? Even if they're not thinking about an object, like this is just the conceptual unit in the program. You want to be able to pass individual vectors to things. And like writing an entire program this way is a big headache. And Intel was like never really able to get people to do that very much, except when they paid them a lot of money to do Intel sponsored demos, right? I don't know. That's an exaggeration. Some people would do this in core parts of the program and whatever. But I think very few people ever wrote an entire program that used data this way the whole time, right? Okay, so this format here, we didn't used to call this anything, but then once this sort of paradigm came around, Intel said like, okay, this, or maybe Intel didn't coin, somebody coined this, right? Probably someone in academia coined this. This is called AOS, right? Which is array of structures, right? And this is called SOA, right? Is a struct of arrays, right? Or structure of arrays. And this is much more efficient for feeding SIMD units. It also has some other properties that are better. Okay, so since the early days of SSE, SSE1, right? We've gotten several versions of SSE. We've got AVX. We've got like ARM CPUs that have like whatever their thing is. I don't know. PowerPC probably has something. ARM has Neon, yeah. So everybody has their own version of this now. And a lot of these actually realize like, oh, we actually want to help people with like loading the data into the thing so that they don't actually have to lay things out in SOA all the time, right? So the problem is not as bad. The problem of feeding these math units is not as bad as it used to be. However, it still is more inefficient to do that, right? So, you know, there tend to be instructions now where you could load 4 X's into here with maybe not that much overhead. It's still overhead that you would like to get rid of though, because the whole reason that you're doing this is to go fast. So you want to go fast. You don't want to go like half as fast as you could, right? And then there are also complications. So even if you have an instruction that says load buff 0, buff 12, buff 24, and buff 36, you know, you may cross like a cache boundary in the middle of this, which can penalize you, depending on the implementation, can penalize you in different ways. And sometimes those penalties can be very bad, right? And so you gotta go fast. It's true. And so, so it's still just better to be able to do this, right? Because you can feed, if you're going through here, peeling off X's, right? You know the X's are contiguous. If you're doing, for example, 4 at a time, and you know that your cache line width is, what did we say? These are 32 bits. So if you know that it's a multiple of 128 bits, then you'll never cross a boundary in just one read, right? And so you can just make things very clean and avoid penalties, right? And that's why you would want to store things this way. Also, there's many other issues, like, you know, maybe I'm DMAing to some coprocessor or some other device that wants these things to be in a particular format and gets even more unhappy. So the thing to understand about general purpose CPUs these days is, so on the one hand, CPUs that we use are astonishingly fast. They are marvels of engineering technology. On the other hand, they're also pretty slow compared to what a special purpose piece of silicon made to do one specific job using the same manufacturing technology, right? Like the same feature size. You know, when people say 10 nanometer, 7 nanometer, right? Using that same feature size, a special purpose device can go a lot faster. And the reason is because CPUs do a lot of things to make them easier to program. Whereas special purpose devices tend not to do that, right? Because the use cases are more specialized, so they can demand more of the people who want to use them, or maybe it's just, you know more specifically what people want to do. So GPUs are an example of that, right? GPUs render graphics way faster than CPUs do. Not necessarily because the underlying silicon is better in some way, although it can vary, right? But it's just the GPUs know what they're doing and they're designed to do that thing. And they're not doing all sorts of like stuff that makes things easier for you, right? And they're very deeply pipelined and all sorts of things like that. That's a whole many lecture topic of its own. Okay. The point being, if you lean on all these things that CPU makers were kind enough to put into the chip to make it easier to program, you're going to take penalties for that. And the less that you lean on those, the less of a penalty you'll take. And as I mentioned, if you're communicating with other things, there's a limit to what I can say here because we have NDAs with many other parties, but I think that from multiple parties, some of this has been discussed, right, in public, but you're going to start seeing computing devices with large installed bases, right, large customer bases that have more and more in the way of discrete additional processors that do special purpose things. And the reason for that is pretty easy to understand. It's like we're kind of reaching the limit of how, in order to deal with Moore's law slowing down, we've gone to this model where CPUs are multi-core, right? And we keep stamping out more and more general purpose cores. And software kind of has a hard time using all those cores very effectively, especially if it's a user program. If you're running a server, maybe you could just imagine, oh, we put a lot more users in parallel in this server. But for like a desktop program, it's getting hard to use all that compute. But if you decide to allocate some die space to doing a different job that you know that a lot of people want to do anyway, then you actually provide additional capability that people are able to use effectively, right? So that's all. Okay, so now SOA is not quite the end of the thing, right? And so the SOA that we demoed way back early, maybe it was 2015, the SOA compiler feature that we demoed was partially about feeding SIMD units and stuff, but it was partially also just about having good cache behavior. So let's talk about that for a second. So let's say you have something that's not about doing math, but it's just, let's say you have a general entity in a game, right? And maybe it's got a position, right? But maybe it's got an ID, right? So, and that's like a U32 entity ID. This is something that you use to look it up in tables or whatever, and to refer to this from other entities without having to use a pointer, right? It might have, it might some flags, right? U64 entity flags. Let's put oh no, this is a better packing. It might have, I don't know, entities have so much stuff. You might cache, so if it's in a collision grid, you might say, U32 cached collision grid index. You'd probably need more information than this so that you know that this is invalid. You might want to do a generational index. Yeah, okay, let's do that, right? So that way, every time you rehash the grid or whatever, this increases, and then you know this is not valid anymore, whatever, okay? So a real entity in a real game has way more things than this, all right? Well, if you have them stored like this, then if you were iterating over an array of entities and you just wanted to test the IDs for something, right, then that's fine. That will seem to go fast because, like I said, your CPU is doing a lot of things to make programming easier. And one of the things it does to make programming easier is it'll prefetch ahead of where you are in the cache, right? So the first time you read the first entity, the CPU might not be expecting that. And it might be, whoa, 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 hold on, we don't have that, right? And then it has to go ask main memory to bring that entity over, right? And that might take a long time. It might take, let's say, 400, 500 cycles to do that, when you thought that this load would only take one cycle or a couple if it was in cache, right? I actually don't know on a current generation Intel chip, I actually don't know how many cycles load from cache is. I assume it's at least 2. Anyway. So then you might say, well, I'm trying to be a cache efficient and cache knowledgeable programmer, but I know that as long as I store all my entities in a contiguous array, then when the CPU brings that first entity over, it'll also actually bring the later ones because it knows I probably also want to look at those, and it's right. So the later ones will be in cache, and then when I get toward the end of the later ones, the CPU will go, aha, he's going through linearly through these things, so let me go get some more before he needs them, right? So modern CPUs are very good at doing this. And it's true. And so as a programmer, I might be thinking, aha, I am using a very cache efficient way of doing things because my entities are packed together in memory, just like these XYZs were packed together. This would be more like, position, I'll put a space, entity ID, entity flags, cache index, I'm going to shorten these names, right? Cache generation, that's for entity 0, right? And then we have entity 1 and entity 2 and so forth. And that's what my memory looks like going left to right. And so I look at entity ID for one entity, and this is slow because we didn't have this available in the cache. But then once we get it, when we go here, the CPU was smart enough to already get this one, right? So we hit it. And then we go here, and the CPU already gets this one. And that is way faster than if you do things the weird object-oriented way, where these are heap allocated, and you're essentially random accessing memory. That is tremendously slower. So this is probably hundreds of times faster, or, I mean, it depends on what the CPU is doing for you, but a lot faster than the Strostrup way of doing things, right? That's not fair, but you know, the way a lot of people writing C++ programs do it, where they new an entity on the heap every time they want one, okay? But it's still not that fast, right? Because as I'm fond of pointing out, current day software is very, 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 very slow, right? And just because you're not very, 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 very slow anymore doesn't mean you're not at least very slow or just slow, right? You want to be fast. How do you be fast? So one thing about this is, well, okay, the CPU might be prefetching these for me, but I'm not actually using that much of the memory it's prefetching, right? I'm just looking at the ID, and then optionally, if the ID matches, then I'm doing something, right? ID is a dumb example because it's probably unique per entity. So you'd probably use a hash table, but imagine I was like checking the flags or something. All right. You know, we're looking to see if a certain flag is set. So many entities may have that flag set. All right. Well, you can end up in this situation when your memory bandwidth limited, right? Because, okay, here's the thing. When Senator Joe Lieberman, or whoever it was, said that the internet is a series of tubes, and everybody made fun of him, they all showed how like everybody who thought they were a smart Twitter internet person made fun of him for saying the internet is a series of tubes, but that's actually what it is, right? And in fact, not only the internet is a series of tubes, but your CPU is a series of tubes, all right? Well, it's a series, it's series and parallel sets of tubes, all right? So there's a tube going from your memory to your cache. You can't just dump a truck on it. There's a tube going from your memory to your cache, and that tube only has a certain bandwidth, all right? You can only fit so much stuff in the tube every second. And in a case like this, especially if your entities are big, even if your CPU is working hard to get all the data through the tube, most of the data it's getting for you is getting thrown away, right? And so you may be limited by the rate at which it's pulling in data that you're throwing away. You know what I'm saying? Like, it can pull in 12 entities per, well, whatever, 12 million entities per second. But if your entities were smaller, it could get 24 million entities per second. And if your entities were smaller than that, it could get 36 million entities per second, because the bandwidth is some number in bytes, right? Okay. That is certainly a thing that could happen to you. So don't forget about the series of tubes. So what do you do about that? Well, you could try to make your entity smaller. You could break it into multiple structs that are stored different places. This is one place where like a component system actually would help you, because like if you have different components and they're stored in different places linearly like this, then you use a higher percentage of your cache. Oh, one question you might have is like, well, if the CPU is so smart, why does it get all the memory? Why doesn't it just get the little pieces of the memory? And the answer to that is, the way caches usually work is they get a range of contiguous bytes that's of a significant size. Otherwise, everybody would go insane. That's just how it works, right? Okay. So this is where SOA can also come in, right? In addition to like just having things next to each other to feed this kind of a thinger, then imagine if instead of setting up my entity this way, we're just going to have 3 because I'll get tired of typing really fast. Instead of doing it this way, you just had position, 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 right? Entity ID, entity ID, entity ID, entity flags, entity flags, entity flags. Let me actually use my Emacs features here, right? So cached index, and then cache generation. I didn't think I was going to type this all out, but whatever. Okay, so you could do your memory this way instead. And let me delete these spaces so that they're the same length. You can see. Okay. Fit them all on one line. Okay. Same amount of memory, arranged differently. Again, not arranged in the way that human beings necessarily like to think about it. But now, if you wanted to go through all your entities and just look at the flags and test them, look, all the flags are next to each other. You'll still take a hit the first time, or you'll still take a miss, right? The first time you look for this memory, it won't be there, and you'll wait. But after that, you're 100% efficient in terms of what you're reading, because it's all next to each other. This, okay, so this was way faster than the heap thing that everybody does, but this is way faster than this. And in fact, you know, depending on the specific system architecture and all this, this both might make your current thread go fast. It might just leave more memory bandwidth open for other threads. There might be a heat impact of not doing this work that allows you not to throttle. Like, there's all sorts of things, right? All sorts of benefits. So it's good to put things together. Except it's really annoying, right? Okay. And then the final thing to say about all of this is that this pattern starts being kind of crappy eventually. All right. For two reasons. One is how do you address the individual elements mathematically? And is that fast or is that slow, right? So if you're doing SOA, like I think here we had 10 things, right? Let's make it 9 things for now, right? So let's say you want to get the first X, right? Let's say we've got buff again. The first X is buff plus 0, right? The second X is, let me label this, X coordinates, right? Buff plus 0, right? Buff plus 4, buff plus 8, and so on, all the way up to buff plus 32, right? Because we said we have 9, and this is the 8th, right? Or 0 to 8, right? And then after that comes the y coordinates, right? So then you've got, well, buff plus 36, buff plus 40, buff plus 44, all the way up to buff plus, is that right? Wait. 68? Yeah. And then z coordinates, let me pad this out. Z coordinates starts, you know, buff plus 68 and so forth, right? Okay. Well, these numbers could be annoying, right? But not only are they annoying, but they depend on the number of items in this array. Okay? So if I have one thing with 9 elements and I want to get the y coordinate, the first y coordinate is buff plus 36. If I have a thing with 10 coordinates and I want to get the first y coordinate, it's buff plus 40, which means that the function that's like loading these things or whatever it's doing with this, it can't like be statically baked in where the offsets of these things are. It has to like know how many elements there are and do a multiply and all that. And that's annoying, right? Whereas with this, if these are tightly packed together into an array, you just know the offset, right? I mean, it's a little bit of a different case. Like you might have a multiply to get to the base of the next entity, but then once you have that base pointer, you have constants, you have known constants to all these elements, right? Whereas here you don't really have that thing. I mean, you might like, you know, depending, I don't know, it's complicated. But the point is, this is annoying and you don't necessarily know as much as you want to. at compile time. But then secondly, what happens if this is really long? What if we have 60,000 of these? We have like 60,000 x's, and then we get to the y's, and we have 60,000 y's, and then we get to the z's, we have 60,000 z's. That's kind of annoying, because then you know you're always taking I mean, we start getting into issues that vary a lot depending on architecture. And I'm not schooled enough on all the different architectures to know what's going to happen. But I mean, there's like cache associativity things that could happen, right? So for example, if you, I don't want to go into a cache associativity explanation. At first, because it's a big topic on its own, and we haven't even gotten to start programming yet. But second, I'm also not an expert in cache associativity. But the upshot is, if you think of a cache as like a hash table that if you think of a cache as like a hash table, in hash tables you can have a situation where multiple items hash to the same element, right? You can have multiple elements in memory hashed to the same location in a cache, and then they can fight with each other, right? They can evict each other, and then you have very poor performance in that case. Whatever. Maybe, maybe I'll go do reading up on some specifics for various architectures, and we'll come back and do a SQL stream about that one. But anyway, whether, you may or may not take a weird penalty from these being far away if you have 60,000 of these. You certainly wouldn't be able to have the option of having them all be close together, which you might want, right? Like you might want, oh, okay, hold on. Let me do this in the reverse order. So the reason, apart from the distance, the problem is if this varies based on the length of the array, you're not in control of whether you will have a cache associativity problem, right? Because it varies. Sometimes with some arrays you will have a cache associativity problem, sometimes you won't, right? So, well, and then the other thing you might want to do is maybe I want to be kind of SOA, but I still want all these things to fit in one cache line or whatever, right? So you might want to go XXX, whoops, I'm capital now, XXXX, YYYY, ZZZZ, XXXX, YYYY, ZZZZ. This isn't going to be like the same number of characters because it was a multiple of 10 or whatever. But you might want this, which is kind of a hybrid of both worlds, right? So this is, hey, it's easy to load into here. We probably get better if we were just going to run through something like this. In this kind of a case, we probably get better memory performance because we visit less wasted memory. And then jump to a next region and then jump to a next region. Although who knows, the jumping to the next region might confuse the CPU, so you might have to prefetch or something, right? But anyway, depending on what you want to do, you might want this instead of this. If you're doing this, how many x's are there? Are there 4 x's? Are there 8 x's and then y's? Right? Anyway, there's very many things that you might want to do. And that was why I felt like this kind of feature should be in user space, or controllable by user space, and not totally built into the language the way I had it in that first prototype. Anyway, this is called, of course, because acronyms have to stack on each other, AOSOA, right? Which is Array of Structs of Arrays. And this is like probably the most controlled highest performance thing for SIMD, right? Where's my Halloween costume? Today for Halloween, I'm dressed as someone who pretends to know how CPUs work, when in reality, I don't know that much. Okay. So, those are the okay, that's a good place to break, actually. So I think next we'll start actually programming now that we've done this intro. Are there any questions on topic, strict on topic questions about what we have covered here? I should join the CPP Standards Committee. No, I should not. Believe me, I should not. Why not both? SOA seems a better thing, not missing the cache. Well, okay, I mean, SOA is basically AOSOA of your array length or of infinity, right? Oh, okay, so let me point out one other thing about this, which is if you're doing AOSOA, you tend to do a block at a time, right? You tend to call a function on, you know, this block and then that block and so forth. And at that point, you get all the benefits of knowing where everything is stored with a constant offset, right? And very often you'll pick these so that they're a power of 2 apart from each other. Maybe not. That might not be convenient, but you know, it could be. And then like bit shifts will get you to the next address, or bit shift and add, or whatever, right? Now you would just, I don't know. It depends. Like what the fastest thing is depends on the CPU. But that's the point of doing AOSOA. Whereas with non-AOSOA, it's like, well, it's a little different. But this, okay, right? I don't mean to say that this is strictly better, right? This is better for some things. Oh, one other thing, actually. If you're talking about this kind of use case, not the SIMD use case, but the just general game data use case, then naive SOA kind of sucks. And the reason why is the following. What if I just want to be able to add and remove stuff from my array? What happens if I've got this all tightly packed together and I want to add one more vector 3? What do I have to do? I have to reallocate the whole damn thing, right? And put a space there and a space there. So I have to recopy all this data, and then I have to put an X and a Y and a Z, right? And so then you'll do a typical strategy to avoid doing it that much, where you allocate extra space that things could grow into, right? But then your SOA is even a little more confusing because you're going to have your extra space at the end. Let's put underscores to represent the extra space, right? And then you have to know not just the length of the array, but how much of it is filled. You have like 2 variables, and thinking about those 2 variables might make you a little bit slower. And then even after you've done this, you still have to take this hit of once in a while, I still have to reallocate this whole frickin' thing, right? And that might lead you to temptations like not contiguously allocating these things because it's such a pain in the butt, right? Whereas with AOSOA, it's a little different. Like you do want to have some empty space, but that empty space is always at the end. Like let's just say we had, you know, one bucket, 2 buckets, right? We have 4 things per bucket. So we have 1 bucket, 2 buckets, and then in the 3rd bucket, we only have 2 things. So you would go XX empty, empty, YY empty, empty, ZZ empty, empty. That would be our 3rd bucket. And so if you were trying to make something that runs fast, you could actually have 2 versions of the procedure that runs on a bucket. You could have the one that runs on full buckets, and that's the one you call almost all the time, and it's maximally optimized. And then just at the very end, you have a thing that just runs on partially full buckets, right? Or maybe, depending on your use case, you can just stuff these with 0 in the end and not worry about it and pass it to the full bucket thing. Who knows? But the point is, if this gets very long and I want to add a new bucket because I have another vector, let's say this one fills up first of all, right? So I put 2 more vectors in here. Now I'm full. I want to add a new bucket. I just put a new one on the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now the question is, if this is all still stored linearly, then I still have to realloc and copy. But you might store it in a 2-level way where each bucket is in like an array, right? And are hopefully contiguously allocated, but sometimes aren't, right? And that would allow you to avoid the copy, right? So what is the smart thing for any of these really depends. I'm not wishing to claim that any of these is the best for any specific use case. I'm just talking about the different things that there are. And what if you have to delete? Well, I would say try not to delete. If you do have to delete, then there are 2 obvious strategies. One is, it's the same as you do for linear arrays. One is just grab the item from the end and copy it earlier. Now that's more expensive in a thing like this, right? If it's a thing like this, then you just grab the entity from the array and it's like 1 mem copy to put it early in the array, as long as you're not a C++ person who tries to destroy and recreate all your things all the time, right? It's just 1 move of memory. In this, it's multiple moves of memory, or in this, it's multiple moves of memory because you have to copy all the things. Hopefully you don't do it that often, or hopefully those moves are all still kind of fast, right? But there are trade-offs to everything, right? And so if you had a situation where you were mostly reordering things and not very often going through them linearly and not very often loading them into SIMD registers, then maybe this is the best one. Maybe the classic way is the best one, right? There's no universal best thing. It's about what are you trying to do and what is going to work best for that. Does the LLVM compiler rearrange data to take advantage of stuff? No, that is illegal in most programming languages. For example, in C and C++, this has to stay in the order that you said it should. And there are good reasons for that, and I'm very glad that they do that. You know, there have been academic projects about rearranging data structures. I don't think those tend to work very well in the real world. Like, I think a programmer who knows how to make things fast is much better at that than a compiler is. How would you implement this in C++? I don't know. You probably could do some really gross template thing in C++, but it would be very hairy. Our goal today is to do it nicely. What tools, if any, do you use to detect and profile cache misses, or is that generally not necessary? You know, there used to be some tools from Intel, like, you know, vTune and like the iPeak tools and stuff that were pretty good at that. The problem is that as CPUs have gotten a lot faster than in the day when I used to use those tools, they don't seem that useful anymore. So like when I try to use vTune today, I downloaded it a couple months ago and tried to use it. It is borderline unusable because it uses like Windows multimedia sampling to see what your program is doing at any given time. And that sampling rate is like every millisecond, which is an eternity in modern computing. Or I think you can do half a millisecond. But that's just forever. I was trying to run it on the compiler to profile the compiler, and no usable data. You would have to run the compiler 10,000 times in a loop, and the program isn't really set up to do that. And so I'd have to do a lot of engineering just to make it vTunable, right? Different platforms have more specialized tools. So for example, game consoles have tools that let you see some pretty good things. Unfortunately, I can't even tell you about those because I'm sure my NDA would be violated there, right? But they're pretty good. But they still are not, you know, they're not foolproof. There are definitely simulator tools where you put your code into them and the simulator says, oh, this is going to be bad, right? You're going to take a cache miss here and whatever. And those can be very helpful, but they're also like simulators. They don't represent necessarily exactly what's going to happen. So I don't have a good solution to profiling those. Fabian might know more if anyone wants to ask him about what's the best way to do it. I actually asked him by email and he didn't really tell me anything, any news I could use, but who knows? Maybe you would get a different result. If you were multiplying multiple members by the same struct with a single scalar, would you want to do AOS? Multiple members, how do you multiply by a struct? Do you mean from the same struct? Multiple members from the same struct with a single scalar, would you want to do AOS so that you got both members at the same time? Yeah, I mean, if they were contiguous in memory, you might want to do that. Okay, I mean, there's all sorts of like, you know, I just wanted to end the discussion there, but it gets really complicated. You know, adding a vector to a number or whatever is a very simple operation. There's lots of things that you might want to do that would mean that maybe this isn't the memory format that you want things in the SIMD registers, right? Maybe you want your SIMD registers to contain XYZ1, 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 because you're going to do some transform or like a cross product or something, right? Who knows, right? Now that said, I believe there have always been instructions to load memory from XXXX into the first slot, second slot, third slot. Like this kind of thing, I believe goes all the way back to SSE1. So this would have been fine, probably. I'm kind of making this up, so it might not be true. But definitely today, going from this to this is fine. But it's just to say that there are many things that you might want to do, right? Like using SIMD effectively is just about figuring out what's the equation you want to evaluate, and then how can you make the instructions do that thing. And it's not always having like by like packed in the same. You might have some really wacky cross terms just thrown in there. Who knows, right? Do you structure your games around SOA up front or later when the expected feature is stabilized? I find it difficult to add modifications to SOA code, TBH. Yes, it is very hard, and that's why a lot of people don't do it, because it makes your code harder to modify, among other things. It makes it harder to think about. Our goal today when we start programming this is going to be to do something that's not hard to think about and not hard to modify. And we'll see, I don't know how good of a job we're going to be able to do eventually. You know, long term, this is a bigger job than just one stream, but we're going to do what we can do and see what happens. A good size for AOSOA is the page size as well. Yeah, quite possibly. I mean, to be fair, I haven't done this stuff in a long time, and CPUs are different from when I did do it a little bit. And when I did do it, I wasn't super serious about it. So the caveat is some of the stuff I said might be wrong. Don't believe me. Believe someone who does this daily, of which there are not very many people in the world, unfortunately. Like, I mean, there's a lot of people at Intel who deal with this daily, but they don't write like serious games that depend on the result being good and also need to do complicated things. Like what'll always happen at a CPU vendor is they'll just say, well, don't do that, right? Do the thing that's fast on the CPU. And it's like, but we need to do that because it's what our game needs to do. That's been the constant tension, right? So, yeah, don't believe me, believe Fabian. If he corrects me on any of this, that's fine. For AOSOA, wouldn't you want to control the stride based on the SIMD capability of the target CPU? Probably. Well, there might be many reasons you want to control the stride. The thing is, if you want your code to be fast, you don't want the stride to vary at runtime, right? So you might bake several different, I mean, thinking about different PC CPUs, who knows? I would probably pick one that is representative, right? Maybe somebody like Rad Game Tools actually detects the CPU and does a lot of different things. But for a game, I would probably just pick one. But I definitely would be like, on something like the PlayStation 4, where I know exactly what the machine is, if that optimum size is different from a typical PC, I would do different code paths. And you don't want those to be dynamic at runtime. You want them to be fully baked in as a compile time option. And that's part of what we're going to do, is make that easy and simple. I'm reading through more questions now. Someone had to say the word protobufs. Kind of goes without saying, but a fixed size array that you never grow and never delete from is also an option. Yeah, I mean, to be clear, this whole growing and deleting is only applies to some things. So, you know, if you've got a game, if you've got Call of Duty, and Call of Duty has some soldiers running around, even though they're animating and they look very dynamic, the mesh for that soldier is probably just like one thing. Like it's one array that's a fixed size that never changes. And because that's very efficient and you don't have to worry about it, right? Actually, in a modern game, especially if you're selling hats, like if you're Valve Zynga Corp, then you probably need one for the base mesh of the guy, and one for the hat, and one for the bling bling belt, and one for the shiny boots that you can only buy in December. But each one of those things is a fixed array of data, right? We like fixed arrays of data in video games. On the other hand, if you're talking about the number of entities in the world, in most games, you just have to vary the number of them. And so, whatever. You know, someone was asking about C++ AOSOA. Edward Komet built it, and YouTube link. Video efficiently coding for modern CPUs. Okay. Check that out if you're interested in that. You worked on Call of Duty and all the meshes are broken up into chunks for culling purposes, FYI. No, I don't believe that. So character meshes are definitely not broken into chunks for, well, if somebody did that to characters, they're on crack, okay? The world certainly is broken into pieces for culling. You don't want to render like an entire world mesh. That's bananas, right? So you definitely want, like, if you have a giant building that somebody's in, you don't really want it to be one mesh, right? But an individual size thing like a character, I doubt that that's most. Okay, let me not say Call of Duty specifically because I've never seen the engine, but most video games would not break a character into multiple pieces, and except for swappable pieces like hats or whatever, right? And then, even if it were multiple pieces, each of those pieces would be a fixed size array. That's the real point of what I'm trying to talk about, is the fixed size array. Characters are separated into several smaller units called serfs. I doubt that that's for culling. I can imagine some other reasons to that, but culling doesn't seem like one. But who knows? Again, I don't know anything about that specific engine. That would seem like a very bizarre choice to me. I'm sure somebody probably had a good reason for that in like 2005, and then nobody ever changed it since then. Okay, let's actually start programming. Actually, let me heat up some water, and then we're gonna start programming this. And we'll see if it goes well. Very short break while the tea water heats up. Any final very serious questions before we move on? Serious questions. No jokey questions. How does SOA affect data layout for sending to GPU? I mean, these days you sort of decide what your data layout is on the GPU. That's the difference between like OpenGL, DirectX 9 and today. Is like your shader decides how it wants to read things and you decide how they should be formatted. And I have not done enough GPU optimization to know what is best in various cases. GPUs tend to store things a little differently in memory than CPUs do and stuff, right? So for example, texture maps on GPUs tend to be tiled for cache reasons. Like they tend to be tiled into squares or tiny cubes if they're 3D. And the reason is because if you're going across a texture, you like don't know what direction you're actually going, right? Well, if your model is scanlining, right? Who knows? Like if it's a tiled renderer, it's even a little bit different, but whatever. But the point is, the direction of travel from one memory location to another is like anisotropic on a texture. You can't necessarily predict which way it's going to be. And so just the way that you set up data for good caching tends to be different if it's spatially correlated data like a texture. If it's something different, just like an array of like particle positions that's not sorted in any way, it might be different. Did we use an SOA system in the witness? I didn't. I don't know if somebody did for other things, but it wasn't a system. It would have just been like, let's copy this data into SOA manually. Okay, I think when we put this on YouTube, we'll break it into two parts. We'll break the previous discussion as part 1, and this will be part 2. Infinite Nest Lives. Yeah, you're welcome for the raid. That was a cool stream to raid. Yeah. I think a lot of people don't get to see low-level stuff like that too often, so it's good. It's good to show. In theory, would SOA layout be more consistent across different hardware performance-wise because the CPU does not need to do any heavy lifting, prediction, etc.? Yeah, probably. I mean, you're less sensitive to memory bandwidth issues. You're less sensitive to various things. What would I do if I were 19 today? Go out and meet girls. No, not really. That's not what I did when I was 19 before, so why do I think that's what I would do when I was 19 now? Go trick-or-treating. Maybe. Maybe. Okay. Well, just like we did on the previous stream, I'm just going to start by... Hold on. Let me get some more water, and then we'll do a clean beginning for the video. You want that in the video. Okay, so this is part 2. We're going to do some programming. If you're watching this on YouTube, there should be a link to part 1 somewhere where we talk about what we are doing here, the ideas behind it. If you're watching live and you just tuned in and you don't know what's going on, then that's Twitch for you. You'll be able to go back and watch the file later on, or you can look on YouTube later. So we want to make a thing using metaprogramming that will produce SOA versions of our good old American apple pie AOS data structures, right? So an example, so I've imported math here in our mostly empty file. And math defines some things, but some of those things are the vectors that we use, right? I'm actually not going to do this yet because I forgot about this stuff. So for convenience of using these data structures, we have like, these are like little swizzles, right? So you could get the X, Y, or Y, Z, or you could refer to things by index. And if we want our SOA thing to ignore all these things correctly, that's like an extra complication. I don't want to think about that yet. I just want to do the good old basic thing first. We'll get that working, and then we can get it working with like stuff like this, right? So what place is it's a different way of doing a union. It's like the go-to of making unions. So what this says is this goes at the same memory address as what X does, right? And this goes at the same memory address as what Y does. And this just lets us do a typed way of getting those two coordinates, right? We don't get all the swizzles like you do in HLSL, but we get those. I don't know if I like this enough to leave it in. I assume this is something Ignacio did or something. It's interesting, but who knows? I mean, like, do we really want all these? Like, really? I don't know. I think this probably makes sense. But even that, like, you could just cast this to the other thing. I don't know. This is all, you know, when you let other people program, they do stuff that you wouldn't have done. That's the drawback. Okay, anyway, we're going to make a copy of vector 3 over here, and it's just going to be like that. They are the cheapest possible swizzles. It is true. Okay. I would have to, like, if I wanted to consider whether I wanted to keep this or not, I would have to just go review how it's being used and how effective is that, and is it something I could do a different way just as easily, or do you lose performance or whatever, right? You don't want to just like go, oh, I don't like it, delete it. Okay. So we want to make something that looks like this. I'm just going to type in what the output struct is, right? We want to make like an SOA vector 3. This is going to be an AOSOA. We're just going to go all the way, right? Well, I'm not sure. Let's just do regular SOA first, so we don't have to think about that much. This is going to be a struct, right? And there's going to be like n elements, right? So that's going to be an int. Let's just say it's 64-bit, whatever. And then we're going to have x is n float, right? Y is n float, and z is n float. The end. Very basic. And we just want to make a thing that transmutes this into this. And then we'll take it further. So how do we do that? Well, let's just say, I have a weird naming convention where I don't like putting acronyms in titles because I like to know what the capitalization convention is. I don't want to have to know if something is an acronym or not. So I usually do this, which looks dumb, but I like it better for various reasons. So we're going to do that. Okay, how do we do this? Well, I'm going to make a struct using the body text feature like we did yesterday. We'll say SOA. I'm just going to call it SOA. We might want a more general name later, right? Of some type T and some N. Well, okay, here's the thing. Yeah, no, it's fine. So body text means that the code in here just generates a string that becomes the struct body, right? It's like not the struct body itself. Although actually I'm getting ahead of myself. Like the thing that we did yesterday was first we just wrote plain old code that generated this. So let's do that actually. Let's just write some code in main that makes this string, and then we'll just put it in there when we're done, because I like doing things that way. So let's just say, for example, T is vector 3, right? We have first class types in this language. We're defining T just to be an alias for the type vector 3. And the reason I'm doing that is just so that the code that I write below is pluggable into here. I'm going to say N is 16, because why not, right? So what do? I'm going to say builder is a string builder, right? Because strings and string building are different in this language, and that's why you can use strings without fear of slowing your program down tremendously. So I'm going to defer free buffers builder. I'm going to say, I'm going to do some stuff, and then I'm going to say S is builder to string. Forgot to take the address up there, right? And I'm going to say print result is, put a new line, comma S. All right. So what is in the string builder? Well, we say info is type info of T. And we'll say incomplete, ensure T is a struct. We did that yesterday. We could actually just go copy that code if we want. We're not going to worry about it yet. We just want to make it work. So for info.members, well, every member has a name and a type. And I actually wonder, I probably have a routine somewhere to print types, but I don't know where it is. We're going to look for that in a second. But certainly we can print the name, right? So we could say, actually, we don't really need to know N right now, because we're just going to say N in the string. So we're just going to say print to builder. Let's not indent, whatever. Name, colon, N, and then whatever the type is, which we don't know yet. I'm just going to leave it like this for a second. It.name, right? So it is the member. We're implicitly using the name from the for loop. And then let's just do that. Ship it. We basically did everything. Okay, hold on. I forgot to say struct here. That's what's going on. It thought this was a function body or a function header, and there's no $signs because I didn't say struct. Okay. Redeclaration of vector 3 because we're still importing math. Get rid of that. I want my simple vector 3. Okay, great. SOA. There we go. Result is x is n, y is n, z is n. So we have to put the type. We could just say float, and that would work for now. But let's... okay. So for basic types... oh, print type to builder. That takes a type info. How great. How great. Print type to builder. Info or it dot type, right? And then print to builder semicolon new line. All right. There we go. Float is an alias for float 32. I don't think we actually preserve enough information to know that I just typed float instead of float 32. That's why this is float and this is float 32. But it's fine. If we get grumpy about this 32, we could remove it later. But the point is, this is a perfectly good body for a struct. Okay? Well, now what? Let's just translate this, or not translate, but move it, right? So we're going to do all this, and then we're just going to return S. All right. So now we should hopefully be able to compile. Nope. Oh, right. Okay. So we had this problem yesterday where we couldn't do this. And in the middle of the stream, I was like, I don't know why we can't do this. I thought about since then why. And here's why. So body text and modify directive used to be the same thing. And in a modify directive, t can't be constant because you need to be allowed to assign it to other things. That's the whole point. I since then actually broke body text to be a little bit of a different thing from modify, but I didn't change the code. So like this is not marked as constant as far as body text knows. So we can't like do this, which is unfortunate. But we should trivially be able to change the compiler to work this way later. I just don't want to go into fixing compiler stuff right now. For body text, t should be constant, but isn't because of body text's history as syntactic sugar on modify, which it actually still probably is. But whatever, we're not going to do that. We're going to say info is cast type info struct of t, and do that there. And that this cast doesn't care if it's constant. Okay, undeclared identifier s. Oh, down here, because we're still trying to print the result. Let's not do that. Okay, so now we don't do anything because we're not ever instantiating this. So let's do this, right? So let's say s is, or not s, well, because we called s the string. This is not a string. Let's say SOA vector, that's a long name, is SOA of n, or of vector 3, 16, right? Let's call this SOA 16, right? And then print well, our print function doesn't print polymorphic structs. So, well, now what? Well, we could make it do that. But on the other hand, what we really care about is the operations, right? Let's just do this for a second. I was hoping that we could do it like yesterday where we just print the struct and it all comes out. But in this case, it doesn't. That's a weird. Why can't I do this? Oh, the caveat that I forgot to say is we're venturing into territory that we haven't really done that much of, which is one reason why we're doing it now. And so several things could happen. We could run into compiler bugs. We could run into me just being confused and forgetting how things work because I don't do it that often. All these things are possible, and we just work through it at this point. So I'm not sure why it wouldn't like me saying SOA 16.x. Oh, no, okay. Duh, guys. It's because I assigned this to the type. This is not an, okay. My print should have worked. You know, remember when I was saying, oh, we don't print polymorphic structs? That's like obviously wrong because we did it yesterday. This is just me being confused and jumping to conclusions. You know the jump to conclusions, Matt, from Office Space? I did that. Okay, here we just assigned this to the type. And so it is, we don't print the whole type, that's true. I should go in and actually print the arguments in the print function. This is just saying this is a type, right? We want an instance of that, so we want to do this. And that's why this didn't work, is like we tried to say, what is the X of a type? And I mean, we could define that as the type of the X member. That just might get really confusing. But this was also confusing. Like, I think the goal should be to give people the best user experience when they make this a mistake, because it's a pretty easy mistake. So maybe this error message just has to get better. Although I could see a case for saying SOA 16.x should be the type and a float. I don't know, man. Anyway, so now let's see. Great. When you actually program, then you have a program at the end. Okay, so SOA 16.x is 16 float 32s. That's great. Let's just print the whole struct like God intended us to do. There we go. Any questions so far? Questions before we move on? Before we move on. So we can, you know, how do you know that this is really SOA? Well, let's just say, see, the thing is, we would like to very conveniently still think of this as an array of vectors, but we can't now because we made an SOA thing, right? So this is the part that gets annoying when you're programming it, right? It's like, so we want, if we want the first X, right? Let's say pointer 0 is SOA 16 dot X of 0, right? And pointer 1, right? Well, it's pretty obvious that, let's cast this to pointer to U8 so we can do pointer math. we take the delta and print delta is whatever delta, right? So that's going to be obvious. It's 4 bytes. But it's clearly 4 bytes from this. And so the thing is, it's nice that we're able to automatically make, let's delete this because that was just an example, right? So really what we're dealing with is this and then this. So it's nice to be able to make an SOA version of this at a given stride. But once we've done that, we have to do this annoying thing still. But so far we have saved ourselves a little bit of annoyance, which is that we could change this struct. Like say I wanted to have a W, right? Well, I didn't have to change anything else, and now it has a W, right? So that's good. We've made a step. What if it wants to have an index? U64. Now it's got an index. Great. So that's all good. Part of the remaining question is like, how do we do this? And then especially, what do we do what can we do to make it easier to talk about and manipulate the elements in here, right? And one answer is, well, you could certainly provide an array subscript operator. I'm not saying this is the right thing because I haven't done it, but you could provide an array subscript operator on this that returns this, right? Oh, and to prove the point, actually, let me make a totally different struct before we go anywhere, right? This looks like a little bit more messy code than this output would have been. Why wouldn't I just do this by hand? And the answer is this works on anything now, right? So you could have entity, right? We had our entity, and it'll have position as a vector 3. Now here's the thing. Our code so far is not going to put these positions, it's not going to strip the X, Y, and Z out of position. It's going to leave each position as an individual unit. That might be what you want sometimes, and it might not. So we might think about adding a recursive option here or something, you know. But we don't have that right now. So this is going to go in. We're going to have entity ID is a U64 or U32, right? Entity flags is a U64, and we had some other stuff, but we don't care, right? So SOA entity is SOA of entity 100 print. So this is where we start getting the win as well, is once we want to start doing this to multiple things, because we didn't, once this is in place, we can just apply it to anything, right? Can you access the recordings and or the beginning of these? Yes, this will be up on YouTube later. I think if you go to the Twitch video page right now, you could see earlier into this stream. I think that actually works. Somebody can give them the link. Use a metaprogram to change every instance of SOA 16 sub n.x in code to something like SOA 16.x sub n. You could do that right now, but that's annoying because then you require people to have a compile time metaprogram, which they might not want. It's also a very heavyweight operation. Now you have to decide, are you doing that operation before you're doing some other code transformation or after? And frankly, it takes time to search for that pattern in the code, and you'd prefer not to do that. But that is a thing that you could do. And I think, you know, from when I've talked to Casey, that's the sort of thing that he leans toward. I haven't talked to him about it in a while, so I don't know exactly. How do you convert to a linear array of floats to send to a vertex buffer? Well, you could just either make a different function, or actually this is a linear array of floats. It's just 3 arrays, but you could cast this to a float star. That would be fine. That would actually work. What would be a good way for recursive SOAing? You would just modify this to recurse down into members. It's a lot like what we did yesterday, right? So, or the day before, when we did, and you can go back if you didn't see that, we did a thing where we were making a command line argument parser, and we made it so that it supports arrays of arrays of arrays of whatever. And when we hit an array, we would just re-recurse into the handler, right? And you would do a similar thing here, but for structs. Wouldn't that have some namespacing problems? Yeah, it might. I mean, if you just pulled something out and it had the same name as something earlier up, then yes. So don't do that, right? Don't name things that way. I mean, really, like that's the right answer in this case. Like some people get all bent out of shape about how to handle that, but it's like, no, like this is a sort of thing that a programmer does when they should know what they're doing. You know, I mean, you could, to be fair, you could just rename it in here somewhere, but like, But isn't it 100 floats of x and 100 of y instead of xyz, xyz, xyz? Yes, that was the whole point. If you, I guess you missed the early part of the stream. That is the whole point of what we're doing. If you wanted xyz, 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 then why didn't you just make an array of vector 3? That already you could do in every language. Okay, let's try this. Now we're venturing into the territory that, dude, I haven't even defined an array operator on anything in many months. So let's have fun with this. Operator, array brackets. How does this even work? Let me just make sure so I don't bite myself. Okay, so yeah, you take an int as the second argument and you return, I think, whatever you want. So operator array brackets of $T, which is an SOA. Have fun with that. And an int, right? And we're going to return T. Well, okay, let's not name this T because we would be returning T.T, which looks like some kind of emoji. And we can't have that. So let's go S for SOA. These don't have to be one character emojis. Okay. So for now, we're just going to hard code this for vector 3, and then we'll generate it, right? Like, I think we would use, I think the best option is to use body text on this. Interesting. All right, let's just see. So let's comment out the entity thing, because we're going to hard code this for vector 3 right now, and I don't want any weird problems due to generating this or whatever. I probably wouldn't actually. Let's see. Okay, so what does this mean? We're going to say result is s.t uninitialized, right? Now, we actually know that this is vector 3, but we're pretending a little bit that we don't know. Okay, and then I'm just going to say result.x equals, oh, I need lowercase, too many, what should I call this variable? Array, or just SOA, lowercase SOA. Result.x is SOA.x sub I, right? Result.y, result.z. SOA dot, right? And then return result. Pretty simple. Let me just see if that compiles. It does. Okay. Well, if we, let's say V is SOA 16 of 5, right? Print type of V is whatever. V equals whatever V. So we're going to print the type first, and then we're going to print the thing. Although, I guess since this is a struct, we'll print the type anyway. Whatever. Whatever, man. I don't know how to program. All right. So it is a vector 3, which means that we got s.t correctly, right? And then, well, it's all 0. And the reason why is because we didn't put things in. Okay. So let's initialize our SOA 16, right? Let's just say let's just make an n here for a second, n, and then we'll say for 0 to n minus 1, SOA 16.x, let's call this I, sub I equals casting that I to float, right? That's what the double X is going to do there. This isn't a variable. We'll probably change this syntax later. Double X is an auto cast operator that just casts the thing on the right to whatever it needs to be to match the thing on the left. This is a quick and dirty. I could type this. We'll just do that. Whatever. Whatever, man. Okay, so Y is going to be minus I, and Z is going to be 1 left shifted by I. All right. So then we'll have, whoops, I, Z. I hope someone in chat caught that. Yeah, someone did. Good. Good. Okay. So now we're initializing, and now when we take V sub 5, right, the X coordinate should be 5, Y should be minus 5, Z should be 32, I guess. I don't know. Yeah, 5 minus 5, 32. So we know that this works, okay? So this is already another good, convenient step. Like, hey, I have this thing, and I can go back to vector anytime that I want, right? So now, what do we do? Well, I would bet, so somebody said that someone did this in C++. I would bet this is a lot better than the C++ version, but who knows? I'm initializing it with SOA syntax still. That is correct. We could make a function that produces an SOA array given a non-SOA array. We could think about that. I'm not sure how worth it that is, but maybe. So now here's a thing that we can't currently do. You would like to say the opposite. You would like to say SOA 16 sub 5 equals V. We can't do this for several reasons. One is that, like, the way C++ does this is with references, and we don't want to do references. Because that complicates the type system tremendously. So typically, we might return a pointer in a case like this. The thing is, there's no like pointer to a vector, right? So you might do this by returning like a temporary object. If it was C++, you might return a temporary object that equals was overloaded on that you would then blah, 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 right? But again, my philosophy on all of that over time has been like, oh my God, dude. That gets really ugly really fast. Nobody understands what's going on. It's hard for the compiler to optimize into fast code, and it complicates the language and spends your complexity budget that you could have spent on something better. So I kind of don't really want to make this possible. I think if you want to do this for now, we would probably just say like set you just use a function, right? Or whatever, which is mildly more inconvenient, but like, oh my God, it's a lot easier to understand. And like when you read this, you know that something is happening here. You know it's not just an assignment, right? So we could do something like this as well. But we're not ready to do anything like that yet, because the fact is that this is hard-coded, and we want to generate this and make it work on entity, right? And there are two ways that we could do it, and I'm going to try doing it a different way. I'm going to try doing it the less obvious way, or maybe the better way. I don't know. Okay, one way that I could do it is put a body text here, right? And instead of having this stuff, right, do the same loop that I did here. And do it here. Maybe we should just do that. But the other option is, in here, when we generate this string, we could also generate the string for the array subscript and just add it to the build, which I think is legal. I hope is legal. You know? So let's actually do it the body text way, and we'll see. I haven't done body text for functions in a long time, so maybe this will break. Who knows? Okay, so this is going to be kind of easy. So we're going to do the same thing here, right? We're going to do the same thing here. And then we're going to do the same thing here. We still haven't made our policy about do we skip some members, right? So if we do that, we're going to have to duplicate it if we keep doing things this way, right? And then we're just going to do this again, right? Okay, well, at the start and the end of this are always going to be the same. They're going to be this declaration of result and this return result, right? So we're going to go append to builder, return result, new line, all right? And before we do the members, we're going to append to builder, result s.t equals dash dash dash. And then just for every member, we're going to say print to builder, right? SOA dot percent sub I, or wait, the other way around. Result dot whatever is SOA dot whatever sub I semicolon new line, it dot name, because it's the same name in both cases. Why was that easy? And then this was harder. Oh, because we had this type. We had to print the type, and here we don't. Okay. I think that's it. I think that's our subscript operator. I might have screwed it up. Who knows? It might not work. Undeclared identifier T. Oh, right, because it's S. Wait. No, S is the SOA. I mean, it doesn't matter necessarily. Let's just make it the vector type. Because we could iterate over the SOA type and pick all the names. But since we iterate over the vector type here, let's make it the vector type here as well. Or whatever it is. The thing that's SOA'd. T is not, oh God. Okay. We're going to do this. So this is another interesting thing where Wait, is S a type info already? In body text? Oh, that's so, okay. These are like old decisions that were made years ago that I haven't like questioned. All right. Let's look at, this actually gave us, so I think in the pre-stream I was talking about this added strings file that contains the things that we output, and I wasn't sure where it was going. I guess we put it in .build now because that's cleaner to put all generated files in one place. We used to just dump them wherever you're running. All right. Okay. We don't work that hard to auto-generate everything, so this is not printing the type there. But this is actually just for this. This isn't for this. So we haven't flushed the file. I think we don't flush the file before we exit. So we're referring to line 16. We don't have 16 lines. So let's try to debug. I don't want to fix compiler stuff today. We're just going to try to debug this without that. But if we have to, we can go fix it. T is not a member of vector 3. Right? It is generated by this body text directive. So why do I think, like, this is the only .t, right? T is not a member of vector 3. It might actually be, I don't know. I don't know. Why do we think T is a vector 3? Let's just print this is a great thing, is because this is just compile time code, we could like put print statements in there and they run. So info that we're getting in this case is SOA, right? It's not the vector. So why? Am I being dumb? Return value of the operator. Oh, wait. Why am I returning a... Oh, no, I am returning a string. No, that's right. T is not a member of vector 3. I assume that's referring to this line because that's the only place where we do a .t. Except for this, but it wouldn't be complaining about this, I don't think. You know what we could do? Just so I don't have to fix a compiler thing. Before we try to make this an operator, right? We can just go like func of this. Because it's the same thing, and we can... that's not really going to help. That's not going to help. I don't think. Let me just change this and make sure that that's the error message. Yes. So it doesn't like, but it's not saying not a member of vector. Now it's saying member of SOA.poly, which makes sense to me. So why did this, what? I don't know about what's going on here. It might be the error message is wrong somehow. Okay, let's go back to the SOA. T is the name of the type, right? Let's make sure, okay, let's make sure that we could do that down here. Whatever is SOA 16.t. Now that's not quite the same thing. Whatever 2 is type of SOA 16.t. Right, so this one is asking about the value, right? And this is the type. So, whoops, type of V. Because we commented out our V for a second. All right. So it's getting it right. So we might have a bug in body text for some reason. Or it could be a totally different issue. What do I try next? So I don't have to go fix a compiler. Result.t equals SOA dot what? No, result.t is not a thing. You would print the generated code and see if the 4 is doing something unexpected. Yeah, normally we would have the generated code. I don't think we're doing anything unexpected, but we might as well take a look at that. Normally we would have the generated code, but I don't want to fix that compiler issue because that's a rat hole. It might be easy, it might take an hour. So let's just do this. Generate, well, let's paste this whole thing. And instead of body texting, we're just going to make the string, right? Generate same stuff. We just return the string, right? All right. So S is result s.t equals dot 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 result. Oh, weird. Okay. Remember when I said it'll be fine to iterate over the struct? The type info for the struct contains the constant members as well. When someone was saying result.t, wait, how did you know that was happening? Did you just know, or did you see that somewhere? Well, I thought that was a suggestion. It was instead telling me what was wrong. That's magical. How did you know? Anyway, I'm not actually sure that this is the problem, but it probably is. It's probably just reporting the wrong line a little bit too. That's why the error message changed when I changed the variable. It's because this line is actually correct. We've got multiple problems. Problem 1, this string isn't getting flushed. Problem 2, it's reporting one line off. The problem was actually here. And that's why we got a different error message when I changed this. This is why we don't, yeah. That was the only other place a T could have been. All right, well, you guys are very smart, and I am fired. That is what happens there. Okay, well, let's fix this. There are several ways we could fix it. Let me just cast back to type. Okay, this is all a little bit weird, right? So the whole thing that started all of this is that inside the body text, S was not a type, it was a type info. And remember what I was saying before about the types not being constant? That was kind of why I gave people the type info. I don't know. These were all just really old decisions, right? So I guess I could cast back to type. I just don't know if I allow that, right? So let's say S2 is cast type info. Is that going to work? Unsupported. Okay, well, when worst comes to worst, you do this thing that is UB in C++. All right. So I think we'll have a stream later where we just go through and fix all these things. To fix, type needs to be constant in body text and not a type info. For clarity, probably all the types should not be. So the question is, in a modify directive, what do you do? Because you kind of want the type info. I don't know. We'll figure that out later. That's a separate stream. This is why I don't want to like rat hole on that, because I don't know exactly the right answer. But so going back to this. Wait, did we finish that? Yeah. Okay. So going back to this, I'm just going to print that. So S2 is the type. So this is gross, but we're going to do it. We're going to do that. We're going to call this S, right? And then right, and then info is type info of S.T. Because I want to do the thing that I said, which is like, let's do the vector type. All right, what did I mess up now? Oh, yeah. Oh, God, right. This actually... This also should be legal. So what it's saying is, so that, you know, there's rules about like this is equivalent to what happens in C++ with like static members or whatever. And I think we may not correctly allow that in all cases. So like S is actually not constant right now because I'm like reading it from memory, right? But S.T is just a constant. And so I should be able to look it up. And I believe in most cases I am able to look it up. But here, I'm going to put this on the fix list as well. Fix. This doesn't work due to complaining that S is constant. Shouldn't it work? All right, well, you know, as I always say, the reason we're doing this is so that you guys don't run into these problems when we release the programming language, right? All of these will be fixed and beautiful. In fact, when I say some of these decisions about how data is passed into like modifying body text were made a long time ago, they were made when I didn't really know how the rest of the language was going to shape out. And so I couldn't really make good decisions about them back then, but now is a time when we can make good decisions about them. So it's time to go clean those up. Okay. How can I do this? Let's not do this. So our other option is to iterate over the struct members and skip the constants. All right. So now, whoops, I deleted this one. Result, colon, t.s equals dash dash dash, right? Okay. We add another to fix one line off when reporting error in operator or whatever for some reason. Got to fix that. Okay. So we're going to take the type info of the struct, and then we're going to go to member. Oh, it's in preload? Oh, it's type info. It's in preload. I'm going to go to the struct member. And the member has a flag on it that tells you if it's constant, right? So I could have done this like 20 minutes ago, and I should have just done it, but whatever. If it dot flags and it dot flags dot constant continue, all right? Ta-da! Why didn't we just do it that way? Because we had to look for all the inconveniences. Okay. Great. So we're going to put this back into here. It's actually shorter than what we had for some reason. So we're putting that back into there and generate, let's delete, let's just be optimistic and comment this out and comment that out and comment these out. And get that, let's just compile that. Undeclared identifier T. What did I mess up? Where is there a T? Oh, it's s.t, not t.s. See, we were printing the string before, but, we weren't actually compiling it, so mistakes like that wouldn't show up. Okay, so that's good. So now let's print the V things. Well, hey, people, we now have a working array subscript that is generalized. And to prove that, let's go do an entity. I don't want to initialize, well, okay. So for we're just going to set the entity IDs, right? So we're going to say E is SOA entity sub 37. All right. Uh-oh. We got to cast this. Because by default, the iterator variable here is an integer, and we're trying to assign it to a U32, which isn't automatically casting because it's information loss. So there we go. We have the entity with entity ID 37. So we went through some effort, but at the end of it, we can now do SOA and subscript on anything, which is great. So we can delete that. We can delete this. We can go back to the added strings file, which hopefully flushed all the way. Yeah. So when we successfully, oh, right. Let's go back here and say ensure added strings is flushed when an error is reported. So it's a little bit funny how we print these things out sometimes, but they're sufficient for debugging, right? So this is like the body of a, an array subscript operator, and then here's the string. We probably should write the parameters and stuff. I just didn't do that. Maybe I was too lazy. Maybe I didn't know how this was going to work out. Like for structs, we kind of write the parameters, but we don't totally do it. And this .poly thing is weird. Like this should all get cleaned up, right? So anyway, here's the function that was generated from the vector3. Here's the one that was generated from the entity. And you can step through those in the debugger and everything, right? There's no mystery magic to it. So that's very nice. Are there any questions about what we have been doing? This might be enough for the stream for tonight. I might want to go out and get some snacks and stuff. And then we could pick it up later. So there are several more things we could do. What could we do? Well, we could implement AOSOA, right? That would be interesting. We could, and then we're kind of in the realm of compiler features, right? So here's a thing. In addition to something like an operator brackets, I have thought about somehow implementing like an operator bracket dot, right? That meant something like this. So like if you said SOA 16 sub 17.x, that this, you could use operator bracket dot to turn that into SOA 16.x sub 17, right? Or whatever, however you wanted to store it. We couldn't have done that before because operator bracket dot would have had to be a macro because of this name element, right? And I think our macros are powerful enough now to do that. But I'm not sure. And so we would also want to do an investigation. Right? Is everything good if we make plain old whatever a macro, right? Or I don't know. You could imagine doing bracket dot where it wasn't an identifier that came in like X. Maybe it was something more like the integer offset, but then you would have to translate the integer offsets from one to another, and that's maybe annoying. So I don't know. But that is definitely a thing that we have thought about. Would that work if you did parentheses? Yeah, it wouldn't be super naive. It would apply to any case where you do subscript and then dot. Now, the reason I'm not super hyped about that is that seems very specific just to the SOA use case. But the nice thing about it is it doesn't complicate the type system of the entire language, right? Because that makes combinatoric explosion of complexity with everything. It's just one feature that kind of lives on its own. And so I'd be more interested in doing that, right? But that's a possible thing. Yeah. Oh, another thing we could do, and maybe we'll do this right now, is what if we want to do an iterator over the SOA and just do a naive one, right? That iterates by vector 3. Like way back in the day, when we were doing our iterator demo, we did a naive iterator that just called bracket, and I think maybe we can do that. So let's go let's go grab this, because I never remember all the parameters, and maybe that's a reason to shorten it. You know, I've been thinking, since we now have a way to substitute different macros, maybe we don't need to make reverse a standard thing in the language anymore. Like, if you want to reverse, maybe you just use a reverse iteration function. I don't know. I'm thinking about that. That would at least cut this down to 3 parameters, and 3 is like a lot nicer than 4, I think. Anyway, well, so this is not a bucket array. This is going to be an SOA, right? And then we're going to say for 0 to t dot n minus 1, right? That's how many things there are. And other than that, we're not going to have to do anything fancy because it's just a single dimensional loop. So we don't have to do anything weird with break or continue or anything. We'll just say insert body, right? We're going to export the it index with the backtick from here, and we're going to say it is array sub it index, right? I believe that should work. Right? So the big finale, if this works, is for SOA 16, print whatever index it is, colon, whatever, new line, and it, right? Something like that. Oh no! Oh, disaster. Okay, this is not good. That was going to be so awesome, dude. So there are some bugs in the for loop expansions that I'm not happy with, and this might be one of them. This might be one of them. I rewrote it after the demo, and like I didn't necessarily. I don't want to have to debug what this is, man. Okay, the very act of doing this for loop is causing the problem. Let me try, just try that. I don't think that'll help. Nope. Well, oh, you think I left out an it index. You are correct. That is not the problem, but that is what I intended to do. I mean, I could try to debug this, but this could be a very, very hairy problem. Bummer. I wanted to do this awesome thing. So it might be that we just have a debugging stream on this particular feature. Because, you know, that would be really nice, again, to just be able to naively iterate over your SOA array just like this would be like, I mean, that's pretty great, right? Let's just name both of these. Right? That's not going to change anything. Yeah, my circular dependency diagrams are kind of useless lately, like something broke. So it just says that main can't compile for some reason. What if I put this into a different function? At this point, we're just trying to tweak around the potential. I don't think this is going to help either. Nope. So there is something about just having this for loop that is bugging us. Interesting. Let's just try to figure it out. So this is a macro expansion that does nothing, right? Oh, we took out our print. Let's put it back. I mean, we didn't take it out. We just moved it to a function that doesn't get called. So there we go. And this should print 0 with a default vector 3, right? Which is all zeros. That's not very useful, but that's what we gave it. So I wonder if the problem is that it's getting confused by a vanilla for loop. Let's try a while loop, like while it index is less than t dot n, we do a thing. We'll insert the body, right? All right. Well, whoops, redeclaration of it. All right. Well, we did it, team. I knew that there was a bug. Like it got to be a bummer debugging this stuff, so I like stopped for a while, and now it bit me live on stream. So this is just a compiler bug. So the nicer version of this function would be to use the for loop, but this is still pretty good, right? This is way better than you'd get away with in C++. So even though we have a list of compiler bugs, I am pretty happy with the output. And we have a subject for another stream. Can you even implement pointer equals true with modifications in the for loop by reassigning the vector in the macro? Wait, what? Reassigning the vector in the macro. I don't understand. Why would iterating by pointer? Oh, right. You mean we have a temporary value. We insert the, oh God. I have to do this. This is gross and stupid, but I have to do it, dude. Okay, we can't do it yet because we didn't write this set function, right? So remember before I was saying that because we're not all C++ sized, we can't do, I guess I deleted it, but we can't do this, right? SOA 16, 5 equals V, right? But we can make like a set function that does that. So let's do that and we'll test it. And then we'll test this. And that could be entertaining. I mean, that's such an amusing suggestion that we have to do it. And I want to do it in time that I could then go to Whole Foods. So, okay. Let's do set. We want the array, we want the index, and we want the value is t dot s, no, s dot t, right? I should make this s and this s and this s. Just being consistent, right? Okay, so we're going to set this. I guess we do another body text with the opposite, right? Right? I don't think there's a cheaper way to do it. This Halloween stream is dope. Yes, it is. This is the most we're finding so many scary compiler bugs. It's a scary, scary Halloween. All right, let's just do this. We might be able to like compress this down. Whatever. Like this is starting to become a lot of code, so it becomes tempting to consolidate the loops and all that, you know. Consolidate loops to shrink code. But for now, we're just going to be dumb because I want to go to Whole Foods and get snacks. So type info struct of s again. So we're going to do this, going to do that, and we're going to say print to builder. Oh, we have to body text up here. And we're going to print to builder just array dot whatever equals whatever semicolon new line, right? It dot name, it dot name. Pretty simple loop. Like by the time you're writing loops this simple, it's like, well, oh wait, no. Right, I didn't get it all. Array dot whatever sub index equals whatever. By the time you're writing loops this simple, this is mostly boilerplate. So we maybe could profitably have combined all of these. I don't know. I mean, we could like do the like whatever. Okay. Mismatching levels of indirection. Oh, I forgot the builder. Bob the builder. Okay, so we're going to print v, and then after set, so we're going to say w is v, w dot x equals 99, w dot y equals minus w dot y, w dot z equals w dot x plus w dot y. Set SOA 16.5 to w. And then we're going to read it back, right? Undeclared identifier x. What did I do wrong? Oh, equals. I hope somebody caught that. I'm sure someone did. All right. Okay, so we say this is v, and then after the set, okay. Wait, what? W dot x is supposed to be 99, but it isn't. But w dot y is minus w dot y. And w dot z is w dot x plus w dot y. So, what? Oh, v dot, I hope somebody caught that. Philip caught it right when I said that. Okay, here we go. After set, okay, so our set function works. And when we iterate, we see that value in the middle of all these other nice patterns. And so now the suggestion was to do this frickin' thing. I'm gonna keep the neat for expansion before I muck it up with this absurdity. So we're gonna say if pointer else this. If it's by pointer, we're just gonna take the address, right? Okay. If pointer set array it index it, right? Okay. So we haven't actually used that yet, but we confirm that it still works. So now we're going to go by pointer and negate x and increment y or something, right? So, or no, negate z. Z is getting a big head, right? Or we'll make z 1 over z. Let's do that. Okay, so let's make this compact, right? Because we're going to do this twice. Let's do this. So we're going to do that. Well, let's just print it twice. So it's the same both times, but we're going to do this. For SOA 16 by pointer, it.z equals 1 over it.z. Uh-oh. This matching is given, oh, set, right. Set wants a value. Didn't work. Why not? That was supposed to be magical. It says it's a pointer to vector 3. Okay, well, in the iterator, we'll just print. Oh, wow. Okay, so why aren't we setting that? Set should work right on Z because it worked right there. So what is going wrong? I mean, if I incremented the index incorrectly, I could see that going wrong. But this is the same index that we do with the body. Oh, guys. Print that back. It is set is setting it, but somehow we're copying this array somewhere. So that is also something we're going to have to look into. I guess I'm not sure why that would happen. Hold on. That's the address of that. And then pre-for expansion is, yeah, these are different addresses. Are they the same as each other? No. Okay, I have bad news, bears. We are, wait, I should have 3 pre's because there's 4 pre's. Oh no, sorry, it's 4 inside 4 expansions. Okay, so E930, EAA8, EC90. I missed one. Oh no, this is an integer for loop. Duh. Okay, those are all different addresses. We have another compiler issue, which is that we're copying the frickin' array when we call the for macro for some reason, which we shouldn't be doing. Does for expansion take a pointer to an object or a copy of the object? So in principle, because it's a macro, it shouldn't matter. It's an interesting question whether you want to let people... It's an open question, like what you want the semantics to be about, like... Maybe macros shouldn't be able to modify things and you should have to pass them by pointer or something. But in principle, I think that's not what it's supposed to be. I think it's supposed to be like it's supposed to be the stuff just goes into the scope, right? And you could modify it if you wanted to, and you're just supposed to exercise caution. Now, for some reason, so because these things just go into the scope, when this thing is getting copied, it must happen at the call site. So this is probably a relatively simple bug. Something in the compiler is just getting confused. And we want to fix that. Anyway, this is good. So we have a list of things to fix. Like none of them are that bad. I don't think I can do this, but let's see. We might have been able to do this. I mean, we'll be printing the wrong thing sometimes. Oh. Like the thing is, yeah, I would have to change some things in the body because you can't just subscript from an array pointer right now because that means a different thing. But the thing that it's complaining about is is the actual call. Okay, so we're not, I could probably do a hack workaround for this like I did with other things, but we're going to do it right. We're going to fix the bugs for SOA 16 doesn't work by pointer because the array is getting copied for some reason. This is an important one to look up because if spurious copies are happening there, are they happening elsewhere, right? Are they just happening in macros, or are they happening for functions a lot of the time and slowing down the game? I don't know. I want that to be the number one that we look up. So next stream, I think we're going to debug these. And then stream after that, I think we do AOSOA, right? That'll be fun. And or look at this and try to maybe combine these into one loop and simplify it down, right? We found a bunch of bugs today, but it's good. None of them are too serious. And all of them just sort of come from, hey, I just haven't played in this exact space, which we should do before we release the compiler to people and tell them to do that. Taking a pointer to an element of an SOA array. How does that work? Am I? Where am I taking a pointer to an element of an SOA array? Oh, here. No, this is this operator that we defined. So the way it works is this gets called, if that's what you mean. And okay, so when taking an address of something like that, I think something like this is illegal in C and older C++, maybe even newer C++. But here, if you have a return value from a function, which is not technically an L value, you're allowed to take the address and it'll just make it an L value, right? Is that a valid address to take? Yes. But anyway, we know that's not the thing causing the bug because when we print this address, it keeps changing. Which is not good. It means we're copying the data, probably, and unless I'm misconstruing. I've already misconstrued several problems. But thank you, people, for coming to my scary Halloween bug stream. It's been good times, and we'll do more. Any final questions, final on-topic questions? In the original syntax for SOA arrays, I remember liking how it was just an SOA token on the array declaration. Am I going to somehow put something like that back in? I don't think so. And the reason is that was something that I was excited about, and it sounds good. So what he's asking, let me just clarify for anybody who doesn't have any idea. There was a thing in the original demo where there were two ways of making things SOA. One way was, you know, if you had a vector 3, you could just say, I forget exactly, but you could say something like array is did it go like this? Something like that, right? But the other way you could do it is you could actually, when you define vector 3, you could say this, and then any array of vector 3 would automatically be SOA. And on the one hand, that sounded neat. On the other hand, there are potentially many problems with it. Like now a library that wants to make an array of your type suddenly has an SOA array and it didn't expect that, right? Or library authors have to think about that all the time. or even just your own program. Like sometimes you just don't want that. And if you can't really control it, you were able to control it by saying AOS. Like you could do this and then do this, but like now that's an additional thing that you have to think about all the time. It just didn't seem super worth it to me in reality. It's one of those features that sounds super cool, but then you're like, I don't know, man, right? But we'll see. We'll see if this is actually something that people want to do and if it makes sense to make it work somehow. Where do the generated functions land in terms of file or global scope? Right now, we just put them at application scope, which is sort of like global scope, except your libraries don't see it. It's probably not the best thing to do that. We probably want to let you, well, okay. We probably at least want to make it be the same scope as the thing that generated it, you know, which is, we're not consistent about that right now. So if you generated it from file scope, it should stay in that file scope, you know, and it doesn't right now. Or maybe we want to let you specify. I don't know. We'll see. Are we going to do another demo in the near future or stick to just dev streams? It depends. I can't predict, man. All right. Thank you, everybody, for coming to Scary Halloween. Let's see who we could raid.
You tell him Ray Bright sent you. He'll beat any price in the
Scary Halloween show. Oh, that's not the right thing. Science and technology. Naive Bot. Open source programming. Fist of the Forgotten. The Lab. Spooky Stream. Solo game development. It's, what language is that?
Right. So I'm just looking at a reference image here.
The text is blurry for me.
Cool.
You guys want me to raid this guy? Is this good? Or do we do someone else? Let's just look for another second. I rated a JavaScript programmer yesterday. I don't know. If people are telling me that's Game Maker, I don't know, man. Is this that same dude who we rated like a year ago? This guy's got my channel open. I could hear my voice in his chat. That's not good. That's strategic. We rated someone like a year ago who was doing a Descent game. Have we rated XRA recently? We haven't. We could do some lurk zone. This looks good. It looks like he's doing some stuff. All right, let's do this. Thank you, everybody, for coming to Scary, Scary, Scary Halloween. And I'll see you later.